Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. When in doubt, choose change. Electricity Class 10 Chapter 11. In this video we are going to learn about electric charge, Coulomb's law, conductors and insulators, types of electricity, electric current, potential difference, Ohm's law, resistance, resistors in series and parallel combination, and Joule's law of heating effect of electric current. Electricity plays an important role in our daily lives. The concept of electricity came into notice due to friction. It actually proves that charges can be produced and they can also be made to flow, and the flowing of charges give rise to electricity. So first learn about friction. Friction. It came into notice when two bodies are rubbed with each other. For example, as you can see in the picture, rubbing of glass rod with silk. When glass rod is rubbed with silk, electrons move from glass rod to silk. Therefore, the glass rod acquires positive charge as it becomes deficient of electrons, and silk will acquire negative charge as the amount of negative charge in it increases. So due to this concept of friction, the concept of charges came into notice, and further Coulomb was the one who gave more information about the charges. So electric charge, it was concluded that we have two types of charges, positive and negative charge. The symbol used for charge is Q and the unit of charge is coulombs, represented by C. Different experiments prove that like charges repel each other and opposite charges attract each other. An electric charge can create a small area around itself where its effect can be felt. It is called the electric field. The electric charge is equals to the number of electrons in it and the magnitude of charge on the electrons. That is, Q is equals to N into E, where N is the number of electrons and E is the charge of electrons, which is 1.6 into 10 to the power minus 19. Now let's calculate the number of electrons in 1 coulomb of charge. So we know that Q is equals to N into E. So putting the values, we get that the number of electrons in 1 coulomb are 6.25 into 10 to the power minus 18. Coulomb's law. According to this law, there is always some force between two charges which is directly proportional to the product of magnitude of the charges and inversely proportional to the square of the distance between them. So in this equation, F is equals to Q1 into Q2 upon R square, and K is the constant with the value of 1. Conductors and insulators. Conductors. Those which allow the current to pass through them are called conductors. They have free mobile electrons like silver, gold, copper, steel, seawater. And insulators are those which do not allow the current to pass through them. They do not have free mobile electrons. Example is rubber, glass, oil, diamond, wood, etc. Types of electricity. There are two types of electricity: static electricity. In this type of electricity, electric charge remain in the position of rest, that is, they do not flow. For example, charges develop when glass rod is rubbed with silk cloth. Second is current electricity. In this type of electricity, charges are in motion. For example, electricity used in our homes. Electric current. The rate of flow of electric charge is known as electric current. Electric current is equals to net charge upon time. And the SI unit of electric current is ampere, represented by A. The direction of electric current is same as the direction of positive charges. Potential difference. Suppose we take two water tanks placed at same level and fill them with water. We connect both of them with tube. Does the water flow from one tank to another? The answer is no, because there is no pressure. What if we increase the height of one tank? Does the water flow from one tank to another? Answer is yes, because water now flow from tank having higher pressure to the tank having lower pressure. Hence, for the flow of water, there should be the difference in water pressure. Similarly, for the flow of electricity, there should be difference in electric pressure, and this difference of electric pressure is called potential difference. So, the potential difference between 2 points is defined as the work done to move a unit charge from one point to another in an electric circuit. So, potential difference is equals to work done upon charge. So, V is equals to W upon Q. Potential difference is measured in volts, represented by V. 1 volt is equals to 1 joule upon 1 C. Hence, 1 volt is the amount of potential difference produced when 1 joule of work is done to move 1 coulomb of charge from one point to another in the circuit. Voltmeter. It is the instrument to measure the potential difference. Electric circuit. It is a closed loop path through which current flows. Circuit diagram. It is the representation of electric circuit through symbols, as you can see in the picture. These are the symbol of some commonly used components in circuit diagram. You can pause the video to see it. Open and closed circuit. As shown in the picture, if there is no breakage in the path of electric circuit, then it allows the current to flow. This circuit is the closed circuit. When the circuit is broken, it doesn't allow the current to flow through it, and this circuit is known as the open circuit. Ohm's law. According to this law, potential difference across the 2 points of metallic conductor is directly proportional to the current passing through the conductor, provided the temperature remains constant. So from this we get that V is equals to IR, where R is the resistance and the SI unit of resistance is ohm. Verification of Ohm's law. First, set up a circuit as shown in the figure. First, use only one cell as a source and note the reading in the ammeter for current and voltmeter for potential difference across the nichrome wire XY in the circuit. Next, connect 2, 3, 4 cells respectively and record the respective readings of ammeter and voltmeter. Calculate the ratio of V to I for each pair of potential difference and current. You will find that approximately the same value of V upon I is obtained in each case. Thus, each graph is a straight line that passes through the origin of the graph. So, V upon I is a constant ratio called resistance. Resistance of a conductor. Resistance is the property of the conductor due to which it resists the flow of electric current through it. So, resistor is the component to measure the resistance. Resistors are used to increase and decrease the current. Rheostat is a device which is used to provide variable resistance in the circuit. resistance is equals to potential difference upon current. So R is equals to V upon I. Factors on which the resistance of the conductor depends. It is directly proportional to the length of the conductor, inversely proportional to the area of cross section, directly proportional to the temperature, depends on the nature of the material. So now we know that R is directly proportional to L and inversely proportional to the area of cross section. So from this we get R is equals to rho L upon A, where rho is the constant and it is known as the resistivity of the conductor, and its SI unit is ohm meter. Resistors in series. As you can see in the picture, when two or more resistors are connected end to end, the arrangement is called series combination. So here R1, R2, R3 are the resistance in series. V is the total potential difference across the wire XY. V1, V2, V3 are potential difference, and R1, R2, R3 are the resistance respectively, and I is the current flowing through them. So total voltage is V is equals to V1 plus V2 plus V3. Potential difference is divided among the resistance joined in series. According to Ohm's law, voltage across each resistor is V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. So putting the values of equation 2, 3 and 4 in equation 1, we get now we know that V is equals to IR, so cancelling I, we get R is equals to R1 plus R2 plus R3. Resistors in parallel. As shown in the figure, the resistors are in parallel combination if one end of the each resistance is connected to one point and other is connected to another point. Potential difference across each resistor is same, but the current flowing through them is divided among the resistances. So as shown in the diagram, voltage across each resistance is same and equal to the applied voltage. Total current is equal to the sum of the currents through the individual resistances. So I is equals to I1 plus I2 plus I3. Now we know that I is equals to V upon R. So from here we can write it down like in this form. And from this equation we get 1 by Rp parallel series, we get 1 by R, R1 plus 1 by R2 plus 1 by R3. Heating effect of electric current. When electric current passes through the conductor becomes hot after some times and produces heat. This is called heating effect of electric current. As you can see in the picture, the examples are bulb, electric iron heater, because they become hot after some time when electric current is passed through them. Cause of heating effect of electric current is, it happens due to the conversion of electrical energy into heat energy. So we know that a battery or a cell is the source of electrical energy. Due to the chemical reaction in this battery, potential difference is generated. This potential difference causes the electrons to flow through the circuit. This circuit has resistors which resist the flow of current, and work is done to overcome the resistance. So while doing this work, the source energy in the conductor is dissipated or converted in the resistors as heat energy. Joule's law of heating effect of electric current. This law states that heat produced in the resistor is directly proportional to the square of the current, that is H is equals to I square, and directly proportional to the resistance for the current. So, and directly proportional to time for which the current flows through the conductors. So from here we get H is equals to I square RT. Electric power. The rate at which the electric energy is consumed or dissipated in the electric circuit. So we can write P is equals to V into I, or P is equals to I square into R, or V square upon R. The SI unit of power is watt, and the commercial unit of electrical energy is kilowatt. 1 kilowatt is equals to 3.6. Thanks for watching. Please do like, share and subscribe.